Who jumps out of perfectly good airplanes in the name of science? Mr. C.
Eighth grade happy downhill day to you, and I have good news. I always have good news, don't I? Don't you look forward to my good news? Or not. Anyway, if you will take all this out, if you will take out the study guide that you got on Monday, I'm going to have you mark it up a little bit more if you haven't already. And hey, you remember that really dumb expression that I used, figure of speech? Oh no, you're not going to use that again, are you? Not the one with the horse? I have to. You can lead a horse to water or to a source of water, but you can't make him drink. I know you've been using this figure of speech. Wherever you go, you love it so much. Or not. What is the parallel figure of speech? You can give an 8th grader lots of information. You can tell an 8th grader what information is going to be covered on a science test, but you can't make him triple R. But I'm trying. So there aren't that many tests left this fourth quarter. How many? Maybe 4. I don't know. Maybe 4. So you want to do everything you can on these tests to pump your grade up or to keep it up. Okay? So anyway, so if you'll take out that, if you'll take out the PTE, the periodic table, if you'll take LS 8 through 12 out, and I'm gonna actually tell you a number of specific, you know how much I love that adjective, specific things I'm going to ask you on the test. Are you serious? I am. Yep. I want you to do well. So anyway, and then, you know, Mr. Phillip has talked with you about bringing a half sheet, half white sheet. I think that's the way it worked. Whatever he said, go with it. So I am all over it. Whatever his parameters are, his variables, you're going with that. So you can write, just fill out that sheet with information that you want to remember. So anyway, I like that. So LS 8 through 12 and then the PTE. Okay, we're going over all of it really quickly. And then I have an awesome video for you at the end on radioactivity that I want you to see, on radiation, kinds of radiation, and it will be really informative. So now if you fall asleep during that video and start snoring, I'm going to ask Mr. Phillip to take your names down and deduct 10 points. So automatically. I mean, this is such a good video. How could you diss a really cool video like this that's coming up? You'll see. Okay. Little bad news. Ingenuity, the helicopter up there on Mars that Perseverance carried up there, postponed its first flight. Was supposed to be tomorrow, but they need to do some software adjustment. Well, the good news is it's not hardware. It's not something that's broke, because if it was broke, they ain't going to fix it. You'd have to go up there and take 7 months to get up there to fix it. So anyway, it's software, so they can fix that, hopefully. So I'm excited about what it does and how it flies and all of that. So I'm looking forward to it, and I'll show it to you when they do it. So don't forget the interactive PTE opportunity. I actually gave a few people that already did it 15 points. So I'm asking you to spend now 5 minutes by clicking on various things. Click on the periods. See the really cool color changes. Click on the families or groups. Click at the top, click to the side. Click on a few elements. And then I want you to click on an element that you really don't know much about at the top on the Wikipedia part up there at the top. click on that and write down 10 neat, complete bullet facts about it. The 10 most important bullet facts that you can find about it. Turn it in. I'll decide whether you deserve 10 or 15 points. The ones I've graded so far were so good I had to give them 15. So, by the way, everything that's come in up on the computer. Any makeups, get them done on 1 and 2 so far. Tomorrow's test is number 3 for the quarter. Like I say, I think after that 4 more we'll probably have 7. So you want to study really well for all of these. Okay? So I better get rolling. On this, I'm telling you what I'm going to go over. I've already crossed off a bunch of stuff. Look down at the bottom. So I've crossed off the gray whale information. I've crossed off Fomin plus B. I'm not going to ask you any questions on that. I've crossed off the top of page 2. And then I crossed off the resurrection information. That'll be on the final, though. So that'll be on the final. I'll ask you, the major thing on the resurrection was there is so much early eyewitness, double E, historical data to the resurrection that even atheistic, I don't believe in the resurrection, people say, but I've got to believe that he came back to life, at least based on the eyewitness evidence, because it was early, really close to when the event occurred, and that's what makes a historical event really solid as far as the data, historical data. And then down at the bottom, all the 7th grade information. It's not for you. That's 7th grade. So you crossed off a lot of stuff, didn't you? Okay. In the top box on the test topics, study it well. All the chemistry stuff in that top box, study it. I'm going to ask you about cloud. I'm going to ask you about nucleus. I'm going to ask you about density. I'm going to ask you about volume. I'm going to ask you about the parts of an atom. Just all of that I'm going to ask you. And the elements. I'm going to ask you about the Standard Model and what it involves. It involves the particles, subatomic particles. It involves electrons, which are leptons. Electron, lepton. They kind of sound alike, don't they? Electron are in the lepton group. And then the protons and neutrons are in the quark group. And I gave you the PQ tip. P followed by Q. Protons are quarks. PQ. Anyway, so you're going to have to not really pay attention to all of this to miss these points. The 4 fundamental forces of matter. Yep, I'm going to ask them. What are they? Electromagnetic forces, gravity, weak force, strong force, and what they are. I'm going to ask you about the Higgs field. The Higgs field gives mass to particles. So I'm going to ask about that. And the Standard Model particles have precise mathematical values, which is strong evidence for design. They were created. So I'm going to ask all that. And then I'm going to ask you to write John 1:3. It's going to be worth 2 points. So, all things were made by him, and without him nothing was made that has been made. And then Colossians 1:17, in him, Jesus, everything in the universe holds together. What 2 answers are you looking for? Holds together. And then on LS8, we've already gone over it. I'm going to ask you about the PTE and Dmitry Mendeleev, first PTE. I'm going to ask you, the PTE points to a pattern that elements have, a pattern. And I'm going to ask you what's in the box on the PTE. Atomic number, atomic mass, chemical symbol, chemical name. I'm going to ask you for the vertical groups. What are they called? Families or groups. The horizontal ones are periods. So I'm going to ask you about that. So that's number 8. Number 9. So what do you have on the left? You've got metals. What's in the middle? Metalloids. What's on the right? Non-metals. So I'm going to ask you about that. What are the metals good at? They're really good at carrying electricity and heat. So I'll ask you about that. The alkali metals are very reactive. I'm going to ask you that. I'll ask you for that adjective. React. And then there's hammering them into sheets. Malleable. Reflect light. Luster. So all of that. The alkali metals are very reactive. This is all from Ls9. The transuranium elements are synthetic or man-made. Down there at the bottom, you can see it. Transuranium, synthetic or man-made. Okay, Ls10 non-metals, not good conductors of heat and light, and they tend to be dull and brittle. Those are the non-metals. This is the non-metal page. I'm going to ask you for a couple of families: nitrogen family, oxygen family, carbon family, hydrogen family, a couple of families of non-metals. And then my pet, this is my pet metalloid. So you love this, don't you, Mr. C? Yeah. What is the number 1 example of a metalloid? Si for silicon. Silicon, not silicone. Silicon. S-I-L-I-C-O-N. S-I. What's it used for? I'll ask. To make computer chips. To make little microcircuits that carry electricity. So, silicon. Si. Metalloids. Okay, that's that. And then Ls11, radioactive, are elements that spontaneously fly apart. They're not very stable. They're unstable, so they fly apart. Radioactive elements. What examples? U and Ra. There they are. U for uranium. Ra for radium. There they are. All of that. So I'm going to ask you about Marie Curie. She discovered radium, and because it was radioactive and gave off those kinds of things that radioactive elements can do, it made her very sick and took her life. She was very brave to study a radioactive element. Again, radioactive elements decay. They break down and fly apart. And you get alpha particles flying out, like I showed you yesterday, and you'll see them again on this video today. Alpha particles, 2 protons, 2 neutrons. Beta particles, electrons, fly out of the nucleus. And then you get gamma rays. And they increasingly get more and more damaging to human and animal cells, plant cells too. So, alpha doesn't penetrate the skin or a sheet of paper. Beta does. It can cause some damage. Gamma really does. You've got to use lead to stop gamma rays. And then, how is radioactivity useful? What do we use it for? We use it for medical tests, like x-rays. We use it to treat cancers. Radiation bombard the cells, the cancer cells, it takes them out. I showed you Palo Verde Nuclear Generating Station, where we control the rate of radioactivity, just the right speed of the breaking apart of the uranium atoms, and it makes heat and makes steam and turns turbines and makes electricity. So, how it's useful, there it is. To diagnose and treat disease, make electricity. PV nuclear generating station that I showed you. And then number 12. Here's number 12. 5 things about valence electrons. This number 5 is all about atoms, how they're held together, and what holds atoms together. There's a certain kind of electron, and they're called valence electrons. It starts with V. So here's what I want you to highlight on Ls12. 5 things. The highest energy electrons are valence electrons. So you're highlighting that. I have circled it. You can see that I've circled valence. Elements have, atoms of elements have 1 to 8 valence electrons. They have 1 to 8. The number of valence electrons determines, I'll ask you this, what does it determine? I've got it right there. Right at the top. What does it determine? You see that? It determines the chemical properties of an element. Valence electrons, highest energy, number 1. Number 2, atoms have 1 to 8 valence electrons. It determines how stable that an atom is. If it's got 8 valence electrons, that's the most stable. So when I ask you how many valence electrons will most likely make an atom of an element stable, 8. Say that to yourself. 8. 8 valence electrons makes an atom stable, so it's not radioactive and flies apart spontaneously. 8. Really important. And then the last thing is the arrangement of those valence electrons in an atom of an element determines what properties it's made of. So there they are again. I'll ask you those tomorrow. What are those V electrons called? Say it out loud. Valence electrons. What do they determine? The stability of an atom. How many valence electrons do atoms have? 1 to 8. What number? Show me on your fingers right now. Do it. Not an option. How many electrons make an atom stable? 8. 8. And then the number of valence electrons determines the chemical properties of an element. There we go, Ls12. Okay, so how much time do we have? Perfect. Okay, now I'm going to give you 2 minutes to look over your PTE. 2 minutes. Look over the symbols. Quick, quick. Look them over. And then I'm going to give you an optional quiz. Optional review quiz or Q. So you're looking over the names and the symbols. And I have 20 to give you. On your white sheet, you're numbering to 20. And then looking over your PTE. Number to 20 on your white sheet. Get ready to put your PTE away. And then I'll ask this. Your homework tonight is triple R, all of this. One minute left. Number to 20 on your white sheet. I've got to hurry because I've got that cool video to show you at the end of the period on radioactivity. It's a goodie. I'll be the judge of that, Mr. C. I guess you will. But what really matters is what I think about it. And I think it's really cool. 30 seconds. Numbering to 20. All you're going to do is give me the symbols of all 20 that I want you to do. 10 seconds. Okay, time's up. So put aside, please, your PTE. So I am going to quickly go through and give you the element name, and you give me the symbol. Okay, it's worth 10 points, half a point each. Here we go. Don't look at anybody else's. Keep your eyes on your own paper. Here we go. Tomorrow you'll have a cover sheet. All right, number 1. I need the symbol for uranium. Duh. Number 2, carbon. Element found in living tissues. Number 3, hydrogen. Explosive, flammable gas on the sun, responsible for fusion. Number 4, gold. Gold. Remember gold and silver. Remember the tip. Number 5, silicon. Number 5, silicon. Number 6, chlorine. Chlorine gas, poisonous gas. We use it in solid form to kill bacteria in our water, in our swimming pools. Number 7, neon. Oh, please. I'm giving you so many of these. Number 7, neon. Number 8, titanium. How easy are these? Titanium, number 8. Number 9, mercury. Mercury, number 9. Number 10, lead. Not so easy. You've got to memorize it. Number 11, oxygen. 11, oxygen. 10 was lead, 11, oxygen. Number 12, iron. Some of these you just have to memorize. 12 is iron. 13, silver. Silver. 14 is tin. Tin metal. 15, nitrogen. Majority gas in our atmosphere on Earth. 15, nitrogen. 16, radium, another radioactive one. Marie Curie discovered it. 17, copper, copper metal, great conductor of heat and especially electricity. 18, I'm going to give you. Name an alkali metal. Just write down one of the symbols. Li for lithium, Na for sodium, K for potassium. Just give one of them. Li or Na or K. Number 9. Number 19. The other gas on the sun. It is a product. It's made by fusion. Helium. How easy is that? Number 19, helium. And number 20, aluminium. I gave you so many clues. Probably 6 to 8 of these. Number 20, aluminium. All right, take out another sheet of paper. I don't have time to go over them again. Here are your answers. Sorry, take out another pen or pencil. Not the one you wrote with. Put it away. Stow it, please. Here are your answers. Half a point each. Uranium, number 1. U. Number 2, carbon. C. Number 3, hydrogen. H. Mark it wrong if you missed it. Number 4, gold. A-U. Gold. A-U. Number 5, silicon. Si. Number 6, chlorine. Cl. Number 7, neon. Ne. Number 8, titanium. Ti. Number 9, Hg for mercury. Hg, mercury. Number 10, Pb, lead. Pb for lead. 11, O for oxygen. O2 to be specific. 12, Fe for iron. Fe, iron. 13, Ag, silver. Ag, silver, 13. 14, Sn, tin. Sn, tin. 15, N for nitrogen. N, nitrogen. 16, radium, Ra. Radium. 16 was radium, Ra. 17, Cu, copper. I gave you 18, Li or Na or K or Rb, rubidium. 19, helium, He. 20, aluminium, Al. Half each. Number right over 10. Take off half for each one you missed. Turn it in if it's a good score. Name, date, period, upper right-hand corner. If you don't put your name on it, I can't give you any points. Upper right-hand corner, name, date, period. Pass that in. And on your white sheet, give me 5 really good bullet facts on this little video and then turn it in. No, give me 6. Half a dozen. And here it is on radiation. It's a good one. 6 bullet facts, please, on your white sheet. Take it away, Mr. Philip. Triple R tonight, big time. And a BFT tomorrow, probably 50 points. Okay, take it away, Mr. Philip.